Hey there, science explorers! Have you ever noticed how things around us are always changing? Ice melts into water, wood burns into ash, and bread turns into toast. These changes are happening all the time, everywhere around us. In science, we call these changes physical changes and chemical changes. Don't worry, these terms might sound complicated, but they're actually pretty easy to understand. Physical changes are like changing your clothes. You look different, but you're still the same person underneath. Chemical changes, on the other hand, are like baking a cake. You mix ingredients together, and they transform into something completely new. So, put on your thinking caps, and get ready to explore the fascinating world of physical and chemical changes. Physical changes are like giving something a makeover. It's all about altering the exterior without touching the core essence. We're just changing how something looks, feels, or its state, but the fundamental nature remains the same. For instance, molding clay into different shapes doesn't change the fact that it's still clay. One cool thing about physical changes is that they're often reversible. This means we can usually get back to the original substance without too much trouble. Think about ice melting. When ice melts, it changes from a solid to a liquid, but it's still water, right? That's a classic example of a physical change. The water can be frozen back into ice and it's like nothing ever happened. When ice melts, it changes from a solid to a liquid, but it's still water, right? This is a simple yet powerful illustration of physical change. We can freeze that water back into ice and it's like nothing ever happened. The substance remains unchanged. Here are some other telltale signs of a physical change. Change in shape or size. Think about cutting paper, folding clothes, or crushing a can. Change in shape or size. Think about cutting paper, folding clothes, or crushing a can. Asterisk change in state. We already talked about ice melting, but boiling water into steam or freezing juice into popsicles are other great examples. These changes are all about altering the form, not the substance. Remember, in a physical change, the substance itself stays the same. We're just changing its appearance or form. The essence of the material remains untouched, showcasing the fascinating nature of physical changes. Now let's talk about chemical changes. These are fascinating transformations that occur all around us, often in ways we might not even notice. These changes are way more dramatic because they actually create something completely new. Unlike physical changes, which only alter the appearance or state of a substance, chemical changes transform the substance itself. We're not just changing how something looks, we're changing what it's made of at a molecular level. Imagine baking a cake. This is a perfect example of a chemical change. You start with flour, sugar, eggs, and other ingredients. Each of these components has its own unique properties and characteristics. You mix them together and bake them in the oven. The heat initiates a series of chemical reactions among the ingredients. What comes out? A delicious cake that's nothing like the original ingredients. The flour, sugar, and eggs have combined to form new substances with new properties. That's because baking a cake is a chemical change. The ingredients undergo a transformation that cannot be undone. The heat from the oven causes the ingredients to react with each other, forming new substances with different properties. This is why the cake is so different from the raw ingredients. Here are some signs that a chemical change might be happening. These indicators can help you identify when a chemical reaction is taking place. Change in color. Think about a banana turning brown or leaves changing color in the fall. These color changes are often a sign of a chemical reaction. Production of gas. When you mix baking soda and vinegar, you see lots of bubbles, right? That's a gas being produced. This is a clear sign of a chemical change. Release of heat or light. When you burn wood, it gives off heat and light, which is a sign of a chemical reaction. The energy released is a key indicator. Formation of a precipitate. Sometimes when you mix two liquids, you get a solid forming at the bottom, which is called a precipitate. This solid is a new substance formed from the reaction. Unlike physical changes, chemical changes are often irreversible or very difficult to reverse. Once the new substances are formed, it's challenging to get back the original materials. You can't unbake a cake or unburn a piece of wood. These changes are permanent, showcasing the power and permanence of chemical reactions. Section 4. Rusting iron, a chemical change in action. You know that reddish-brown coating that forms on iron objects when they're left outside in the rain? It's a common sight, especially in areas with high humidity or frequent rainfall. That's rust, and it's a perfect example of a chemical change in action. Unlike physical changes, chemical changes result in the formation of new substances. When iron is exposed to oxygen and water, it undergoes a chemical reaction called oxidation. This process is a fundamental example of how elements interact with their environment. This reaction creates a new substance, iron oxide, which is what we call rust. Iron oxide has different chemical and physical properties compared to pure iron. Rust has totally different properties than iron. It's not just a change in color, it's a transformation at the molecular level. It's weaker, more brittle, and it has that telltale reddish-brown color. This brittleness can lead to structural failures in buildings, vehicles, and other iron-based structures. Once iron has rusted, it's very difficult to get it back to its original state. Removing rust often requires strong chemicals or abrasive methods. Rusting is a slow process, but it happens all around us. Over time, even the strongest iron structures can succumb to rust if not properly protected. Think about old cars, metal fences, or even tools left out in the elements. These everyday items show how pervasive and persistent rust can be. So, next time you see rust, remember, it's not just iron changing its look, it's a whole new substance being formed. This transformation is a vivid reminder of the power of chemical reactions in our daily lives. Section 5. Baking soda and vinegar. A bubbly chemical reaction. Here's a chemical change you can try at home, with an adult's permission, of course. If you mix baking soda, sodium bicarbonate, and vinegar, acetic acid, you get an instant chemical reaction. You'll see lots of bubbles forming, which is a sign that a gas is being produced. This gas is carbon dioxide, and it's the same gas that makes soda fizzy. The reaction also produces water and a salt called sodium acetate. This reaction is a great example of how chemical changes can be fun and exciting. Section 6. Physical versus chemical changes. A summary. Let's recap what we've learned about physical and chemical changes with this handy table. Feature: physical change, chemical change. Definition: alters the form or appearance of a substance, but not its chemical composition. Results in the formation of new chemical substances with different properties. Reversibility: usually reversible, often irreversible or difficult to reverse. Examples: melting ice, cutting paper, boiling water, burning wood, rusting iron, baking a cake. Key indicators: change in shape, size or state, change in color, production of gas, release of heat or light, formation of a precipitate. Section 7. Conclusion: the ever-changing world around us. As you've learned today, the world is full of fascinating physical and chemical changes happening all the time. From the smallest atom to the largest star, everything in the universe is in a constant state of flux. By understanding the differences between physical and chemical changes, we can better appreciate the complexity and beauty of the natural world. So keep your eyes peeled, and you'll be amazed at the incredible transformations happening right before your very eyes.